say to describe the table, the directions say, does the table represent a function, yes or no? And so that's what we're trying to figure out. So remember, listen carefully, students. Each input must have one output. Here's a 5. It has one number over here. Here's 6. It has one number. Here's 7. It has one number. Here's 8. It has one number. So yes, this is a function. Why? Because each input has exactly one output. Okay. Now, by the way, just for the record, it's totally okay to have more than one. It's okay if each output has more than one input. That's fine. But each input has to have exactly one output. It's very important. If it doesn't, then it's not a function. Number 11. 1 has one number over here. 2 has one number. 3 has one number. And 4 has one number. So yes, each input has exactly one output. So yes, it is a function. Yes. Number 12. Okay, now here's where it gets tricky. This 9 has one number here, but look, this 9 has another number. So the input of 9 has two different outputs. Now, listen carefully. If this would have been a 5, that's okay, because your output for 9 is 5, and your output for 9 is 5. So 9 still has one output, 5. That's totally fine. This would represent a function. 8 has one output, 7 has one output, and 9 has one output, because here your output is a 5, here your output's a 5, and that's okay, that's fine. But that's not what we have. We have 9 giving us an output of 5, and 9 giving us an output of 4. That means 9 has two different outputs. 9 has an output of 5, and 9 has an output of 4. So that only has to happen one time for the entire thing to fail. So this chart right here, this table, does not represent a function. It does not. Okay, numbers 13, 15, and 17, they want us to make an input-output table. Okay, so I'm going to put N abbreviated out. I'm going to make an input-output table for this function. Not being very neat, but that's good enough. And if you'll look at the directions carefully, students, it says to use 0, 1, 2, and 3 for your input. Okay, so that's going to be our input, and we're going to use that in our equation. So my input, we studied this in your notes, remember. Input is almost always your x, output is almost always your y. Okay, so for my input, I'm going to pick this 0 up and put it in for x. So y equals 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is 2. Alright, now I'm going to put 1 in for x. So y equals 3 times 1 plus 2. Here's my x, I'm going to put a 1. Alright, 3 times 1 is 3. Plus 2 is 5. So my output is 5. Alright, next I'm going to substitute 2 in for x. So 3 parentheses 2 plus 2. 3 times 2 is 6 plus 2 is 8. And lastly, I'm going to substitute 3 in for my input for x. So y equals 3 times 3 plus 2. 3 times 3 is 9 plus 2 is 11. And so there's my output, 11. Okay, so there's a very nice input-output table for this function right here. Let's try number 15. Alright. Okay, here we go. My function is So where the x is, I'm going to substitute 0, so y equals 5 times 0, which is 0. Next, I'm going to substitute 1 in for x, so y equals 5 times 1, which is 5. So my output is 5. My input is 2. So y equals 5 times 2. So if my input is 2, my output is 10. Alright. Next, I'm going to substitute 3 in for x. That's my input. So I have y equals 5 times 3. So when 3 is my input, 15 is my output. And there we go. An input-output table for this function right here. Okay, number 17. Alright, here we go. Where the x is, I'm going to substitute 0. So I have 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. So there's my output. So when 0 is my input, 1 is my output. Next, I'm going to substitute 1 in for x. So 2 parentheses 1 plus 1. 2 times 1 is 2 plus 1 is 3. So when my input is 1, my output is 3. Next, I'm going to substitute 2 in for x. That's my input. 2 times 2 is 4 plus 1 is 5. So when my input is 2, my output is 5. Now I'm going to substitute 3 in for x. So 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. So when my input is 3, my output is 7. Okay, not too bad. Here we go, moving on to numbers 19, 21, and 23, okay? We're going to make an input-output table for these values right here. Let's see. The directions say 1, 1.5, 3, 4.5, and 6. Alright, so there we go. And let's get started. Here we go. Actually, we're going to slide this over a little bit. And there we go. Alright, now I'm going to substitute 1 in for x, so I have 4 times 1 plus 2.5. 4 times 1 is 4. 4 plus 2.5 is 6.5. Okay. Next, we're going to substitute 1.5 in for x, so 4 times 1.5 plus 2.5. 1.5 times 4 is 6.0, or just 6 in other words. So 6 plus 2.5 would be 8.5. Alright. Next, we're going to substitute 3 in for x, so 4 times 3 plus 2.5, that would give you 12 plus 2.5, which is 14.5. Alright, now we're going to substitute 4.5 in, so 4 times 4.5 plus 2.5, so here we go. 4.5 times 4 would be 20, carry a 2, 18.0. Okay, so 18 plus 2.5 would be 20.5. And then lastly, we're going to substitute 6 in for x right here. So 4 parentheses 6 plus 2.5, that would be 24 plus 2.5, which would be 26.5. Okay, I hope that helps. Number 21. Alright, here we go. Let's make an input-output table for this function right here. where the x is, I'm going to substitute 1. So 9 over 1 plus 10. 9 over 1 is 9. 9 plus 10 is 19. Alright, let's substitute 1.5 in. So 9 over 1.5 plus 10. That's the same thing as 9 divided by 1.5. Move the decimal one place. Move the decimal one place. So now I have 15 going into 90, and 15 goes into 90 exactly 6 times. So 9 divided by 1.5 is 6, plus 10 is 16. Okay? Moving on to number 3, putting 3 in for x. So 9 over 3 plus 10. 9 divided by 3 is 3. 3 plus 10 is 13. Pretty simple there. Alright, moving on to substituting 4.5 in for x. So 9 over 4.5 plus 10. Okay, so here we go. We have 9 divided by 4.5. Now remember, students, you never want a decimal outside the box. You've got to move it over here so it's gone, okay? So I move the decimal one place so that it's gone. Alright. But if I move this decimal here one place, I have to move this decimal one place too. It's here. And now it's here. So I have a 0. 45 goes to the 92 times. So 9 divided by 4.5 is 2. Plus 10 is 12. Okay. Alright, moving on. Lastly, let's substitute 6 in for x. So we have 9 over 6 plus 10. Now, 9 over 6 is the same thing as 3 goes into both these numbers. So 9 over 6 is the same thing as 3 over 2. Okay? I reduce the fraction by 3, and 3 over 2 is the same thing as 1.5. So if I have 1.5 plus 10 more, that's 11.5. If I have $1.50 and I add $10, that means now I have $11.50. Okay, so there's a really nice input-output table for this function right here. Alright, last problem, we're finally done. Here we go. Let's substitute 1 in for x. So we have 1 squared minus, remember students, 0.5 is the same thing as 0.5. I'm just going to put 0.5. 1 times 1 is 1, and 1 minus 0.5 is just 0.5. How do I know that? Well, 1 minus 0.5. Remember, when you're subtracting numbers, you got to line up your decimals. The decimal for the 1 is right here. So you have to line up your decimals. 1.0 minus 0.5. That becomes a 0. That becomes a 10. 10 minus 5 is 5. Bring your decimal straight down. 0 minus 0 is 0. So 1 minus 0.5 is 0.5. Alright. Next, we're substituting in 1.5. So I have 1.5 squared minus 0.5. So 1.5 squared. 1.5 times 1.5, 24, carry 2, 7, 15, it's 225. We have one decimal place here, one decimal place here, so go over 2 places, 2.25. So 1.5 squared is 2.25 minus 0.5. So 2.25. Now watch, I line up my decimals, minus 0.5. So I can put a 0 here and a 0 here. 5 minus 0 is 5. Your 2 becomes a 1. This is a 12. 12 minus 5 is 7. 1 minus 0 is 1. Bring your decimal straight down. And there we go. 1.75. Alright. Okay, now we're going to substitute 3 into our function. So I have 3 squared minus 0.5. 3 squared is 9. 9 minus 0.5, so 9. My decimal is there, minus 0.5, so put a 0 here, put a 0 here. You can't do 0 minus 5, so make that at 8. 10 minus 5 is 5, 8 minus 0 is 8. 8.5. Bring your decimal straight down, 8.5. Alright, now let's substitute 4.5 in for x, so I have 4.5 squared minus 0.5, so here we go. 4.5 times 4.5, 5 times 5, 25, carry your 2, 20 plus 2, 22. 5 times 4 is 20, carry your 2, that's 18. So we end up with 20.25, one decimal place here, one decimal place here, so go over two places. So 4.5 times 4.5 is 20.25 minus 0.5. So 20.25 minus 0.5. 0 here, 0 here, 0 here. 5 minus 0 is 5. You can't take 2 minus 5, so make your 2 become a 1, that's a 10. Make your 10 become a 9, that's a 1. 1 and 2 is 12. 12 minus 5 is 7. 9 minus 0 is 9. 1 minus 0 is 1. So 19.75. Okay. And last but not least, then we're finally done. We're going to substitute 6 in for x. So 6 squared minus 0.5. 6 times 6 is 36 minus 0.5 is 36 minus 0.5. Decimal here, put a 0, 0, 0. 0 minus 5 we can't do, so make this 6 a 5. 10 minus 5 is 5. 5 minus 0 is 5. 3 minus 0 is 3. Bring your decimal straight down. 35.5. And that, my students, is an input-output table for this given function right here. Okay, I hope this homework help video has been a help to you guys. If you have any questions at all, please don't hesitate to call or email.